I'm going to record this in case I think Jolene's the only one here. Hi, Jolene. Hi, Jolene. And Jared Watson was absent last period. I don't think Jared's watching, but maybe he will.
I hope he heard that.
Okay.
Did you say?
These trig identities are on your formula sheet. So you probably want to have your formula sheet out because when we get to the back, these won't be on your notes for you to look at. Okay? The formula sheet, yours is not blue like mine is. We don't get colored paper anymore, but looks like this. On the back, there's a nice trig grid. Represents basically the unit circle, but not in a circle. 6.2 day 2. Alright, so on the front, we're going to start out with some really easy rewrite and equivalent forms. Okay, so sine of 45. Remember, 45 is the angle. That's your theta. So we'll find the formula that tells us what sine is equal to. So sine of theta equals 1 over cosecant. So this would be 1 over cosecant of 45. You just fill in 45 for theta. Okay, those are equivalent forms, kind of like 2/4 and 1/2. Those are equivalent forms of a fraction. These are equivalent forms of a trig function. Okay? Sometimes when we're simplifying, this one might be more useful than this one, because we might be able to cross things off or whatever. Now the next one, tangent of 50. Who thinks they could write tangent of 50 in an equivalent form? There are 2 answers to this one. Get your formula sheet or up at the board at the formulas. Tangent of 50 would equal what? Yeah? Yes, that's one of them. Tangent of theta equals 1 over cotangent. Tangent of 50 equals 1 over cotangent. And then what's the other one that tangent is equivalent to? Look right below it. You got it. Now, when we get to the back, you will use what I call context clues in the problem to determine which of those 2 to pick from. Based on the other trig identities in the problem, you'll think like, oh, if I put it like this, then the numerator and denominator will like cancel out or something. So that'll help you figure out which one of these 2 to pick. Okay? Because you won't write both of them, you'll just pick one of them. And then secant of 20, secant is equal to 1 over cosine. So 1 over cosine of 20. See if you guys can do the next 3 on your own. We'll go over those. And we're starting off real easy until we get to the third from yet today. Cosine of 60 equals, Emily?
1 over
secant. Very good. E, cotangent, 25 equals, Erica?
1 over tangent 25 for cosine 25 over sine 25.
Perfect. This is the one that has 2. Tangents and cotangents will have 2 equivalent forms. And cosecant of 18, Jenna?
1 over sine.
Perfect. So literally, if you think this is easy, the back is basically the same thing. There's just going to be more going on. There'll be more than one term, and you'll have to figure out which one to rewrite. Now, another element that is going to come into play is sometimes the angles won't match. So we will have to use the complementary angle theorems.
I love that.
2 angles are said to be complementary if they are both acute. What does acute mean? Small, but more specifically, less than 90.
Oh, sorry. I got the other one. It's going to be larger than 90.
Okay. Complementary angles are both acute, and they will add up to be how many degrees? 90. Supplementary was 180. Complementary was 90. You know what? All right, now I want you to grab your formula sheet and I want you to flip to the back of it with this chart. Okay? Now, this chart is really user-friendly because you have degrees in one column. Guys, can you please stop talking while I'm talking? It's really starting to irritate me. Thanks. Degrees in one column and radians in the next column. So guess what? If you want to convert degrees to radians, you actually don't have to use the formula if they're one of these measurements. Just look beside it. Okay, so this can convert for you, which is really useful because it has a lot of the angles that you'll see. Now it also tells you what the sine, cosine, and tangent. Those of you that took pre-calc, this is your unit circle, just not in a circle form. Okay, this is in a chart form. We'll use the circle form of it later in the year, but right now I'm just going to give you this chart. So go to 45 degrees, go over to the sine, and identify that it is square root of 2 over 2. Write that down. Okay, also 45 on our chart, go over to cosine, it's also square root of 2 over 2. Okay, so those are the same. What do we notice about the angle measurements? 45 plus 45 gets me. So these are complementary angles and they happen to have the same value. Okay? Now notice the next ones, 30 plus 60 also gets us 90, so let's see if they also come out to be the same. So go to 30 on your chart, over to sine, we get 1/2. Go to 60, travel over to the cosine column, and we should see 1/2. Okay, so these are just like a little mini proof or explanation of why the theorems below work. These complementary angle theorems are also on your formula sheet. Okay, they are right below the other ones. These are used to convert an angle to a different measurement. Okay. So put that in your notes, and you might actually want to write this on your formula sheet. Used to convert angle measurements. Now, all of these are in degrees. All of these formulas also work for radians. Okay. Jot that down, also work for radians. Then you remember what 90 degrees was in radians. If you're not sure, flip to the back of your chart, find 90 degrees and look right next to it. Pi over 2. Okay, so also works for radians, just jot down, use pi over 2 instead of 90. Okay, but some of you will actually want to convert the radians to degrees and then just use the 90 formulas. I'll show it both ways when we get there. So again, technically you could replace all these 90s with pi over 2 if the problem is in radians. Alright, so we're going to do 3 of them. We're not going to do all 6 because we're on a shortened class schedule today with our delay. We'll do 3 of them just to give you the idea before we start the back problems. Now, reading the directions, this one says use the complementary angle theorems above to rewrite. So we're not going to rewrite this as 1 over cosecant like we did in the beginning. We're going to rewrite it using these angle theorems. So sine of theta is equal to cosine of 90 minus theta, which theta is 45. So cosine of 90 minus 45 will be cosine of 45. That's your answer. These are equivalent forms. Again, we kind of proved that when we just did it above. They were both square root of 2 over 2. Okay, the next one is tangent of 50. So we'll use this formula for tangent of theta equals cotangent of 90 minus theta. And theta this time is 50. Which will be cotangent of 40. You don't have to put the degrees every time if you don't want to. So we'll have a lot of those. Alright, now, pi over 3. These are in radians. Okay? So if you're going to leave it in radians, you'll use the secant formula, but instead of doing 90 minus, we would change this to be pi over 2 minus theta. So I'm going to show it this way first, and then I'll show if we convert to degrees second. You guys can pick whichever method you like better. So we'll use this formula, secant theta equals cosecant of pi over 2, which is 90 degrees, minus theta, which is pi over 3. Now, in order to add or subtract fractions, we need a common denominator. So the common denominator would be 6 So we'll rewrite this one, multiply this one by 3, multiply this one by 2. So we'll have 3 pi sixths minus 2 pi sixths. Just subtract the coefficients. 3 minus 2 is 1. So my answer will be cosecant of 1 pi sixth or just pi sixths. All right, now let's suppose you don't like that. Here's an alternate method. You could convert pi over 3 to degrees. Again, go to your chart on the back, find pi over 3 in the radians column, and go over to the degrees, and you'll see that it's 660. So you could change this to degrees first. A lot of you may like this method better. Then you would just use the 90, okay? So secant equals cosecant 90 minus theta, which is 60 in this case, to get cosecant of 30. Don't leave that as your answer though, okay? This is degrees. If the question is in radians, your answer has to be in radians. So if you choose this method, you then have to go back to your chart, 30 degrees, pi over 6. A lot of you will find that easier than having to find a common denominator. I don't care which way you do it. Okay, we're gonna skip the next 3 and go to the back where we're gonna apply all of these things. Again, you're gonna wanna have your formula sheet handy because on the back of the notes, none of the formulas are there for you to look at. Okay, I'll have some of them up on the board, but so we'll skip those. All right. So on the back, we're going to see a bunch of expressions, and the directions ask us to find the exact value of the expression by simplifying using identities. Okay? Just as like a little bit of directions, maybe you write down at the top of your notes. The first thing you want to do is you want to check the angles are the same. If the angle measurements are not the same, you will have to convert one of them using the complementary angle theorems that we just did. So like tangent of 50 can become cotangent of 90 minus 50, tangent 40. Okay? So looking at these, 40, 40, and 40, we're good to go. They all have the same degree. All right, the second thing we're going to do is we're going to rewrite, I'm going to say one or more expression using identities. So this is like what we did at the beginning where we said sine of 45 is equal to 1 over cosecant of 45. Just like copying in to the formulas, rewriting. And then step 3 will always be to simplify. A lot of times things will cancel out in the numerator and denominator. And there's more than one way to do this, depending on which trig identity you choose to rewrite. So we see 2 expressions. We see tangent of 40, and we see sine 40 over cosine 40. So you can either rewrite this one using one of these, or you could rewrite this bigger one. If you look, sine theta over cosine theta, go backwards, the equal sign, you can switch them around, is equal to the tangent. So sine 40 over cosine 40, using this identity, tells me that this is actually the tangent. Remember that these identities, since they have an equal sign, they go both ways. Remember, that's called the symmetric property. You can flip them around. And then I'll show this the other way in case you don't like it. What do you think tan 40 minus tan 40 would be? 0. That's your answer. You need work to support it though. Okay. Now, let's suppose you don't like that, and you would prefer to change the tangent 40 because it looks more easier to use since that's on the left. You would change tangent of 40 to be sine 40 over cosine 40, and then you'd leave the second one as is, and it's still going to be 0 because anything minus itself. So it doesn't matter which of these you choose, but you need the work to support your answer of 0. A lot of them will come out to be 0 or 1. Not always, but a lot of the time they do. All right, next one. Check your angles. Slight delay here. 48, 48, so we're good to go. Okay, which one do you want to change? Do you want to change tangent or cotangent? It does not matter. There's no wrong answer. First person to tell me what they want to do is what we'll do. Oh, you said different things. Mackenzie said tangent. It doesn't matter. So, go to your chart that I have on the board. Which of those two do you think we would pick? The first one, right? Use your context clues. We see a cotangent, that one has a cotangent. So we'll make this 1 over cotangent of 48. Now the cotangent, I'm going to leave it as is, but I'm going to put it over a 1. And the inverse of multiplying is dividing, so these cancel out. We're left with then 1 over 1, which is 1. Okay, you could test these in your calculator if you were in degree mode, but all right, now we get into some problems. The angles don't match. So we need to make them match. Doesn't matter which one you change. Okay, I'm going to change the second one because I have more room to write on this side. All right, now the formula, I don't have those formulas up on the board, so grab your formula sheet. You're going to be using the complementary angle formulas. So on here it says cosine theta, and I'll write it on the board, equals sine 90 minus theta. You may want to drop that in your notes just so that when you're looking back you have an idea of where we pulled this from. Okay, plug in the numbers. So cosine of 53 will be equal to sine of 90 minus 53. 90 minus 53 is 37. Weird how they match. So we're going to get rid of this and replace it with the equivalent value, sine 37. Now the other one, we want to leave it alone because it looks a lot like what we have here. What do you think I'll get when I add sine 37 plus sine 37? Let's think about algebra. I heard someone say it. If I asked you what x plus x was, 2x, right? 1x plus 1x is 2x. So 1 sine 37 plus 1 sine 37 will be 2 sine 37. So this is one where it didn't have to be 1 or 0. Doesn't happen a lot, but it does happen sometimes. Now, had you have chosen to convert this to 53, you could also get 2 cosine of 53. Like, I would have both of those on my answer key if I were checking, because it would depend on which one you converted to which angle. They just have to match, doesn't matter which one matches. Okay. Next one, they also don't match. Ooh, they're radians too. So most of you don't like radians. Okay, so let's go to our chart. What is pi over 6 in degrees? 30. So let's change this to be tangent of 30. Minus cotangent, what's pi over 3? 60. I'm getting these all from my special angles chart. Angles don't match. Which one do you want to change? 30 to 60 or 60 to 30? 60 to 30. Okay, the second one. So we're going to change our angle using the change of angle formulas, the complementary angle formulas. So I'll drop that one down. Cotangent of theta equals tangent 90 minus theta. So tangent of 90 minus 60. Surprise, surprise, we'll get tangent of 30. Usually they pair up the numbers so that you'll get the same. So get rid of this. This is now tangent of 30. Tangent of 30 minus tangent of 30 will get me 0. Okay, so I'm essentially, can I just guess on the test? I got a 50-50 chance, 0 or 1. but they'll usually be 3-point problems, so you do need work to support your answer. All right, now let's add in more terms. So we have 3 things. First of all, what operation is going on between these 3 things? Multiplication, okay? And checking our angles, we can see we have 2 43s and then we have 1 47. So I'd probably change the 47. Otherwise, you have to change 2 43s. So less work. All right, so go to your change of angle formulas, which are on your formula sheet. Secant of theta equals what trig function of 90 minus theta? Secant, yeah. Secant theta equals cosecant 90 minus theta. So off to the side, we're going to do secant of 47, which will equal cosecant of 90 minus 47. The biggest mistake I'll see is that you guys will just change this to be secant of 43. You can't keep the trig identity the same and change the number. Okay, make sure you use the change of trig formula. So we're going to get rid of this and replace it with that. I'm just going to copy everything else down. So now we're in all 43s. Okay, now we need to start rewriting stuff. So I have them up on the board, but you also have them on your formula sheet. My 43 here looks like a Y. Let's fix that. Tangent. Which of these 2 do you think we should pick? Here's the second one. I'm thinking the second one also because if you look ahead at the cosecant, cosecant is 1 over sine. Sorry, Belle. I'll finish this one on the video, but alright, I'm going to finish up the note examples that we didn't get to in class in case you guys are struggling on your homework. So at this point, we did get all of our angles to match, and we had just talked about how it would be best to do this formula for tangent because we looked ahead to see that cosecant is 1 over sine. So it would be helpful if we had sine and cosine in our answer. So I'm going to rewrite this one as sine 43 over cosine 43. So we rewrote that one. Bring our time sign. Cosecant, come over to our formula sheet, is equal to 1 over sine. So I'll make this 1 over sine 43. Okay, now you can see that's going to be useful because we have sines in the numerator and denominator. Now looking ahead, we have cosine of 43. If you notice, we have a cosine of 43 already. So I'm going to leave this one alone and just bring it straight down. Cosine of 43, and I'll put that over a 1. And then we know that the inverse of multiplication is division. So we're able to undo multiplication with division and multiplication with division. So we end up with 1 over 1, which gets us an answer of just 1. Okay, next one. First, check our angles. We see 40, 50, and 40. So we need to change the angle using the complementary angle theorems. So sine of theta is equal to cosine of 90 minus theta. So just plug in the angles. Sine of 50 will equal cosine of 90 minus 50, which will get me cosine of 40. So I'm going to get rid of this and make it cosine of 40 over sine of 40. Now, it's up to you whether you want to change cosine over sine. If you look at your formula sheet, cosine over sine is equal to cotangent. Or if you want to change cotangent into cosine over sine. Doesn't matter which one you choose. So we could rewrite this as cosine 40 over sine 40. And anything minus itself gets us 0. And the other way to do that would have been to leave the first one as cotangent 40, to change this to be cotangent 40, and subtract those, you would still get 0. Doesn't matter which one you do, but you have to have work to support your answer. All right, I'll also go ahead and do the closures in case you guys are really struggling, just to see a couple more. First, check our angles, 10 and 80. Different. Doesn't matter which one you change. Literally, you can change this one or that one. I'm going to use my change of angle formula, which is that sine is equal to cosine of 90 minus the angle. So that will be...
Please excuse the interruption. Alexis Durbin, please go to room 126. Alexis Durbin to room 126. Thank you.
So this will now be cosine of 10. Cosine of 10 divided by itself. Think of even just numbers. 10 divided by 10 is just 1. Make sure you don't think that's 0. You would still be left with 1 over 1, which is indeed 1. And our last one, we have 35, 55, and 35. So we need to change this to match the other ones. We know it's going to come out to be 35, but you can't just make it secant of 35. We have to use the formula for secant, which the formula for secant is that it equals cosecant 90 minus theta. So it'll be 90 minus 55, which will get me cosecant of 35. Then we need to start rewriting. Tangent. Look at our formula sheet. And we have two options for tangent. Which one do you think would be the best option looking ahead at the other problems? See, cosecant and cosine. So I'd probably choose the one that has the cosine in it. So I'll make this sine 35 over cosine of 35 times, we have the cosecant. We got rid of this. It's cosecant, which is 1 over sine, times cosine of 35. Now you could change that to 1 over secant, but if you look back in the problem, we don't have any secants. We do have a cosine, so I'm going to leave that cosine over 1. And then see if we have any inverse operations. Multiplying and dividing, multiplying and dividing. So we're left with 1 over 1, or just 1. Then your homework is to complete the 6.2 worksheet 2. It is a front only.